Dear lecture series on computer graphics. In today's video lecture, we will be discussing about Bresenham's line drawing algorithm. So Bresenham's line drawing algorithm uses simple computational techniques. Uses simple computations such as addition, subtraction, and multiplication for drawing a line. So since these are basic computational techniques, this algorithm is called as an efficient algorithm. So we are not facing any problems such as DDA algorithm where you use to round off locations. So round off is used to calculate the floating point operations, and floating point value when you try to round it off, its complexity will be drastically increased, so that the algorithm efficiency will be compromised. But in this algorithm we don't have any kind of round off operation, so this will be efficient in computing the raster locations in line. Now this algorithm chooses the optimal raster locations. So optimal raster locations for drawing a line, So raster locations is not a new term. Raster locations are nothing but it is called as a pixels. So it is pixels. You will be identifying the optimum pixel to draw a line using this algorithm. So let us have a close understanding of how this algorithm operates. Okay, now I'll take up an graph where it has x-axis and y-axis. I want to draw a line from P1 to P2. Let us take up this line is called as a true line here. Now when you take up the point P1, there is not any problem because it is exactly intersecting. It is starting with the point where x and y axis intersect. But when you take up the second point here, it intersects in this area where you have 2 points in between. That is, above you have one intersecting point and below you have another point. In these 2 points which you have to take. So here comes the problem. Say for example, this is the actual intersecting point, and the distance between this point and this point is called as distance below. It is called as dB here. And this point and this point, between this and this, is called as distance above. Now I have 2 points here. In these 2 points which I have to take. So Bresenham algorithm uses a simple technique where whenever a distance between a true line, the point which is having less distance from the true line will be taken into account. For example, if dB value is less, then the point above, then the point below will be taken into account. Suppose if dA is less, then the point above the true line will be taken into account. So this way, and the same pattern will be followed for here also. When you take up this is called as an intersecting point, and this is called as dB, distance below, and this portion is called as dA, distance above. So from this diagram you can easily understand that dA is having less distance than dB. So this point will be taken into account. So Bresenham algorithm actually uses a decision parameter to identify the raster locations here. So this raster locations, whether you have to take a point below the true line or above the true line, is actually decided by the decision parameters. And now this decision parameters are used to select the point above or below the true line. Used to select the points which are above and below true line. So, as far as Bresenham algorithm is concerned, line drawing algorithm is concerned, it operates based on three cases. That is, it computes the value of the slope. So, the value of slope m is computed. For drawing any line, you need two values, two coordinates, that is x1, y1 and x2, y2. So slope value can be computed just like m equal to y2 minus y1 by x2 minus x1. So this is the way how to compute the slope. And the difference between y2 and y1 and divided by the difference between x2 and x1. Now we'll go and calculate the value of m here. Suppose m actually falls under three categories, and the difference of between y2 and y1 can also be said as delta of y, and difference between x2 and xy is also called as delta of x. Now we'll go and compute, explain about the categories in slope values. There are three possibilities. Now what are the three possibilities here? Now if m value is less than 1, if m value is less than 1, that means the value of delta x is greater than delta y. In this case, what you have to do, if m value is less than 1, then you have to compute, you have to increment the value of x in unit terms. That means xi plus 1 is equal to xi plus 1. Now, and yi plus 1 depends upon the conditions. Okay. Now, if m value is greater than 1, that means delta of y is greater than delta of x. So in this case, y will be incremented in unit terms, that is yi plus 1 will be incremented by yi plus 1. So yi is the current location, yi plus 1 is called as the next location. And when you compute x of I plus 1, then it has to compute it based upon the decision parameters. Suppose if you have m equal to 1, the third case, that means delta of x is equal to delta of y. In this case, both x and y has to be incremented in unit terms. That means xi plus 1 should be incremented by xi plus 1. Then yi plus 1 is equal to yi to the power 1. So this has to be incremented in this order. Now we will go and work upon the algorithm on the first case if m is less than 1. So if m value is less than 1, then what you have to do? Now you have to compute decision parameters. So the decision parameter is, first you have to compute what is meant by delta x, and delta x is called as x2 minus x1, and delta y is called as y2 minus y1. Okay. Now after this computation, you have to identify the decision parameter. So decision parameters is called as dp. So decision parameter is called as dp. So initially this dp should be computed as 2 delta y minus delta x. 2 delta y minus delta x. For example, if dp is greater than or equal to 0, if dp is greater than or equal to 0, then what you have to do? You have to increment the value of xi plus 1 is equal to, you have to increment the xi in unit terms, xi plus 1. And similarly, you have to increment the value of yi plus 1 also should be incremented in yi plus 1 unit terms. That means both the values of x and y has to be incremented in unit terms. Now, again, whenever the dp value is above 0, then you have to compute dp value once again. Initially, you have to use this formula 2 delta y minus delta x. But when you compute the decision point next time, if the dp value is greater than 0, then you have to use dp should be computed as dp. Now let us assume that this is dp I plus 1, the next term, and this is dp I plus e. 2 delta y minus 2 delta x, where you can use, since m value is less than 1, you can use y k plus 1 minus yk. So this is the formula. This formula can be applied only if decision point is greater than 0. Now, what will happen if the decision point is less than 0? So if decision point is less than 0, then you have to compute increment x of I plus 1 in unit terms, xi plus 1. Every time xi will be incremented by 1. But yi plus 1 is equal to yi. That means you are not going to increment the y value when the decision point value is actually less than 0. So this point you can just do it like this, yi plus 1 equal to yi. Now how will you compute decision point if the value is less than 0? That is, if the value is negative, then what you have to do? So simply you can do like this, dp of I plus 1 is equal to dp of I plus 2 delta y. So simply you can compute like this. So all this algorithm can be applied only in case of m is less than 1. If m is less than 1, then you have to apply this algorithm. So how many times you have to apply? So you have to apply, repeat the iteration. The iteration has to be done. How many times it has to be done? It has to be done del x times. Since del x is incremented in unit terms, it has to be done in del x times. Now what will happen if m value is greater than 1? So if m value is greater than 1, that means del y value is greater than del x. Then how will you compute it? For example, you know that del y is equal to y2 minus y1 and del x is equal to x2 minus x1. So now to do this, you have to compute the decision parameter initially. So initially the decision parameter, a slight variation from where m is less than 1. Here m is greater than 1. So decision parameter dp is equal to 2 delta x minus delta y. So this will be done initially. for calculating the decision parameter here. And next step, if dp value is greater than or equal to 0, since m value is greater than 1, here y will be always incremented in unit terms. So yi plus 1 is equal to yi plus 1. So the value of next value of yi plus 1, that is, I have to write a subscript like this, that is y subscript I plus 1 is equal to yi plus 1. And similarly, if dp value is greater than or equal to 0, x subscript of I plus 1 is equal to incremented by xi plus 1. And to compute the decision parameter, when the value is greater than 0, then you have to use dp equal to, that means dp of I plus 1, that is the next decision parameter, is dp of I plus, instead of 2 delta x minus 2 delta y. Have to just reverse it. 2 delta x minus 2 delta y. Since your m value is greater than 1, you have to do xk plus 1 minus xk. xk plus 1 minus xk. Suppose, what will happen if dp value is less than 0? If dp value is less than 0, then you have to compute yi plus 1 is equal to yi plus 1. So yi doesn't have any issues here. But xi plus 1 is equal to xi. That means x value is not getting incremented. So when m value is greater than 1, only the y will be incremented in unit terms, whereas x value should be decided based upon the decision parameter. How will you compute the decision parameter when the value is less than 0? Again, if you want to compute the decision parameter when the value is negative, then you have to use dpi plus 1 is equal to dpi plus 2 delta x. So this way you can compute it. So thanks for watching the video. Have a good day.